all water is not the same. Only 1% of the world's water supply is considered fresh water, and there's a projected increase by 40% in water demand by the year 2050. Furthermore, a projected 37% increase in energy demand by the year 2025, and a corresponding growth in energy supply will be needed to support this. Unconventional oil and gas are two of the fastest growing energy sources in the United States and may be key to doing this. However, over 1 billion barrels of water are used a year for hydraulic fracturing, and over half of this is spent to deep injection wells afterwards. Given the current water scarcity and decrease in oil prices, our solution greatly decreases both the cost and the impacts of hydraulic fracturing, and unlike most other solutions, does so today.
Standard well pad operations look something like this. During the fracking process, up to 1,000 trucks will bring in 300,000 barrels of fresh water. Approximately 40% of this volume returns as flowback and must be disposed. 60% of the total cost of water spending is transportation alone. Our solution is a water management program that utilizes two non-freshwater sources, brackish water and flowback. Water initially flows from brackish wells, receives minimum pretreatment, and is used as fracking fluid. The second part of our solution begins once the contaminated flowback returns to the surface. The flowback passes through our mobile treatment units to remove water hardness, oil, scaling compounds, and suspended solids. Each skid has a throughput capacity of 10,000 barrels per day using customizable equipment that includes chlorine dioxide treatment, oil water separators, sand filter, and water softeners. After treatment, the water is then pumped through temporary piping to be reused in the fracking of nearby wells. BP will act as a third-party water provider for operators, ensuring excellence through safe practices. As a first mover, BP diversifies its revenue stream in a growing market catalyzed by increasing water scarcity.
Our solution recognizes that providing millions of gallons of water is not just a treatment issue, it's also a logistics issue. Per barrel profitability relies on water quality, quantity, and proximity.
This diagram compares per barrel water costs for each step in the hydraulic fracturing process. In ideal situations, such as multi-well pads, transportation and storage costs are minimized, and the treated flowback can be reused for optimal savings. These savings range from 25 cents to $5 per barrel. A standard Eagle Ford well requires 300,000 barrels of water. At 10% of our maximum profitability, we will earn 50 cents per barrel of gross profit. When we consider the $50,000 operating cost, this results in $100,000 of profit per well. Operating the unit for 70% of the year yields $3.6 million of profit per year. Factoring in the R&D costs, one unit is $600,000, putting the ROI at 6 weeks.
Here in Texas, over 90% of the top producing wells are in areas of high water stress. Across the nation, freshwater use has caused friction between public municipalities and operators. Additionally, health risks involved with deep well injection and water use have caused some state legislators to push for fracking bans. Globally, foreign countries that can operate at lower oil prices put U.S. domestic production at risk, and globally puts over $800 billion of investment in the energy industry at risk. These factors call for the immediacy of a solution that reduces the water consumption and cost in the hydraulic fracturing process. Our solution uses proven technologies to reduce CapEx costs and provide a solution to tomorrow's growing problems today. As Roden Analytics, we support
Safety,
courage, one team,
respect,
excellence, and
we care deeply about how we deliver energy to the world.